So here I go again. I'm teaching you about diamonds and rubies, other stuff. Okay. One of the things about a diamond is that it's just carbon. Okay, and that means that all the atoms are all the same size, right? Bum, 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 bum. I mean, these are more or less the same size. And they line up in rows and columns. Bum, bum, bum. But they line up in a staggered fashion like this. So there's, two up on top and two up on the bottom, and these guys in the middle. So if you and when you stack spheres that are all the same size, um, together they create something like this. So there's a hexagonal component to the stacking order, um, even though they're cubic. Okay, and this is a cube. This is actually a piece of calcite, which is calcium carbonate. Okay, and if you look at the, let's see if I can put this down this way. Probably not. All right. Well, boy, if you count the sides there, 1, 2 up by my finger, 3, 4 on either side, and 5, 6 poking down into the middle, you'll see that a cube, when you look at it 45 degrees out off of the corner, has 6 sides also, and the top 3 gummies here make the shape of a box, for one thing, and they also look disturbingly like the top of a quartz crystal, what we call quartz. Okay, quartz is supposed to be 7 on the Mohs scale of hardness. So, for instance, if I take a ruby, nice little ruby like this, and I come over here to my calcite, I leave a big old chunk out of the middle, right? And you can see that baby where I just scratched it. I can go like that, and the scratch is still there. Um, okay, and you got to wipe it off. If you don't wipe it off, you don't know. Um, okay, but for instance, if I take my ruby and I come over here and I try to scratch my little table that this is sitting on, I can't scratch it. Okay, so it's not glass. Glass is 5.5. This is 4, I think. Yeah, calcite is 4. Glass is 5.5. Ruby is 9 on the Mohs scale of hardness, and it's been bugging around my shop, so don't pay any attention to the dirt or hemp seed oil or scratches, because I can take them out. But can't scratch a little table. I didn't put that in there. I don't think I did. No, I didn't. Not with this thing, anyway. And the same is true with this bluestone. Okay? I can't scratch this bluestone with my ruby either. It just skates off of it. It's like like skating on ice, and you can feel the difference. On this one, you get a drag across it, not on that surface so much, but like on this surface, you can feel it and hear it. This, granted, this is really shiny, but if you look, this has also been buying around my shop in the same container. It might have a little hemp seed oil on it, but it does not have any scratches. And diamonds sparkle around the periphery. And so it's a nice little diamond. Just cut the old-fashioned way. This is not cut like De Beers diamond. And we use a handheld diamond cutter to do it. So these are faceted. Each one is individually faceted. And I like these cuts better. I think they're fascinating and beautiful, and give you all kinds of interesting things to do. All right, so the other thing you can do, of course, is shut my light out and check with a laser. Okay, and see how it's glowing over there on the other side? That's because the carbon-14 is busy giving off electrons. Okay, and this has carbon in it too, right? The calcite is calcium carbonate. It glows. Ha ha! Because of the same thing. My little spheres. And this guy. Look at that. Oh, wow. That's something. Now this guy, rubies, also light up pretty good in the red. Diamond will glow in green really good. Green lasers, I don't happen to have mine handy at the moment, but the clear ones will glow in all colors. And most De Beers diamonds are clear diamonds. They don't get very deep over there in South Africa. These come from China. The kimberlite is much deeper. So, rubies, on the other hand, don't particularly do much with blue light except eat it. It's not coming out the other side. Don't ask me where it goes, man. Because I don't know. Isn't that strange, huh? I mean, it just goes away. It lights up a little bit, but and it's doing something in there. It's got to be doing something in there, but it's not coming out. So there are other things, that will glow, like calcium carbonate or plastic. Plastic is made out of carbon. This stuff over here, this one here, are, I think, if you take a look, let's see if I can turn the light back on. Yeah. This is called botryoidal chalcedony. And the botryoidal means grape-like. Okay, so that's what these little bots are, the little dot things. Um, and it's a cool stone. This is a cool stone. This came out of the Gila River up by Safford. And we also mine fire agate up there, which is botryoidal. Um, and it makes this stuff. Isn't that neato, huh? And I'm just working on this one, so. But it's got some neat colors in it. Look at that stuff, man. So we'll have this one cleaned up pretty quick here. Another one. These guys are not from Safford. These are from, I think, Agua Caliente, Mexico. Sonora, state of Sonora. I live in the Sonoran Desert. And we've got lots and lots of rocks here. Real cool ones. So this is a fire agate, and where'd my little piece go? Supposedly quartz, yeah? Um, okay, and I'm going to get you a little closer here. There you go. Hey, there's a crystal there in the middle that I think is diamond. Let's see if I can hit it. Where'd the damn light go? And yeah, it glows like a diamond does. And it's surrounded by what I think is silicon carbide rather than silicon dioxide. And it's 10 on the Mohs scale of hardness, so you cannot scratch it with a known diamond. It will, however, glow in all wavelengths. If I could find my other laser. Where did my other laser go? There it is. And so, but not quite as good, right? Because there's some different stuff in there. The silicon participates in the double bonding that happens with carbon because they're both semi-metals in the periodic table in the same column. So they're related to each other. And when carbon precipitates out of molten rock, it's the only thing that's there. Nothing else is solid at that point in time. And the next thing that happens is the free carbon as the melt starts to cool down. The free carbon and silicon, the carbon starts to form crystals. And the silicon mixes with it freely because they're attracted to each other in a positive and negative sort of way. There's more energy in the silicon to get the silicon out, and it has a lower melting point. So the higher temperature and those rows and columns that I talked about allow the silica to move along those rows and columns between the atoms of carbon. And that's how silicon carbide forms. And it is this stuff. And I get it, some of it's real clear. And they call it moissanite in the stores and sell it as imitation diamonds. And I get it out of the Gila River for free. This stuff is silicon carbide, 10 on the Mohs scale of hardness. And I've been doing this for about 40 years along the Gila River here, from Silver City, New Mexico, all the way down to, well, where I live here in Goodyear is on the west side of Phoenix, on the west side of the Sierra Estrella, but all the way down to going towards Gila Bend, which is heading towards Yuma. So I've been doing about 300 miles of this river and its tributaries. A lot of my stuff come off of what the river they call the San Pedro. So anyway, these rubies came from elsewhere. These are from India, I believe. And they're nice ones, man. If you want to know what a pigeon blood ruby looks like, there you go. That's a pigeon blood ruby. The real thing. That's a nice one. And you know what? People can say things and say blah blah blah, but if they don't show you the numbers, if they don't show you the math, it's just blah blah blah. Science is all about measuring the world we live in, and not measuring it with some machine you don't understand. If you push a button and it does something you don't understand, measuring something you don't understand, and you get a number from it, all you have is a number. You don't have any understanding. Right? Knowing how to push a button and get a number is not knowing what you're looking at. It's knowing what you're told to do. So, education is not something that comes free, right? Usually. And I got mine at the library mostly. And out in the desert picking up rocks. And you know what I did? For years, I carried around a field manual for rock collectors. Just regular people, not graduate level geologists or anything, man. Golden books of minerals, or field guide to minerals, I guess. Golden book field guide to minerals. And the guy starts off with a pretty good description of how to test minerals, including the hardness test, specific gravity, streak. Those are the three that I use for the most part. And those things don't require a machine that you don't understand. They do require a little, like a scale and a cup of water, maybe, um, or the ability to calculate the volume of this, right? If I know how much this weighs, I divide the it's weight over volume. So I'm dividing the volume into the weight, um, and then I know what the density of the material is. For instance, silver is about 7. It has a specific gravity of 7 times more dense than water. A gram of water is 1 cubic centimeter. A gram of gold is 19.3. I mean, this cubic centimeter of gold. Sorry. Whoops. Cubic centimeter of gold weighs 19.3 grams. So silver weighs 7 grams. And that's the variation between like silver and gold. Okay, so I have lots of things that I tell you, oh yeah, that's gold. And you go, oh, well, got a bunch of it, man, if it is. And it actually is, because I checked, right? And I didn't check with a machine I didn't understand and didn't really trust anyway, back of my mind. I checked with a scale and measurements, right? Because I can measure the length, the width, the depth in anything, just about, in a circle. Pi r squared gives you the area of a circle times however thick it is. That's how you measure a coin. And see the little bumps, everybody wants to give you 47 decimal points and stuff. It's unnecessary. You can get a pretty accurate number with just doing what I just did. This is about 3 centimeters, so 1.5 times pi, 1.5 squared times pi, actually. So 45, 4.5 times pi, 12, something like that. Yeah. Anyway, my head is doing other things at the moment, and I use a calculator too a lot of times, so that I don't make mistakes if I have important numbers to use. We're in abacus. Abacus's work. Science is about mathematics. It's not about blah, blah, blah. It's measuring what we are looking at, so we know what we're looking at. And it doesn't take fancy equipment. It takes a little bit of education. And education is the very best. Education is the very, very best investment you can make. I got mine at the library, you guys. I was working and supporting a family. Peace.